Over the last few months, a GitHub repository named Andrej Karpathy Skills has amassed over 54,000 stars and 4,600 forks. The repository consists of a single plain text markdown file. Senior engineers are actively bypassing heavy, multi-layered AI coding tools in favor of dropping the static text file into their project root. This shift points to a specific challenge in modern development. Current large language model coding assistants are volatile and non-deterministic. Left to their own devices, these models make blind assumptions, execute without seeking clarification or managing their own confusion. Raw AI intelligence deployed in a production environment becomes an operational liability if it lacks rigid structural constraints. And unrestricted AI tends to overcomplicate simple logic and bloat abstractions. A request for a simple 100-line feature results in a 1,000-line speculative construction. Forcing this bloated module into the architecture causes the model to silently delete unrelated existing code. The model rarely surfaces inconsistencies, presents architectural trade-offs, or pushes back to suggest a simpler approach. These silent hallucinations and unprompted deletions destabilize pipelines, introducing errors into previously stable code. Relying on ad hoc individual prompt engineering fails to prevent this systemic code degradation. Controlling the model requires a localized global control mechanism. Instead of fragmented prompt engineering, developers inject a single CLAUDE.md file directly into the project's root directory. Manual step-by-step imperative prompts are inefficient and prone to human error. A deployable rule set applies the exact same structural logic to every interaction automatically. The file acts as persistent system context, overriding the model's default completion behaviors. Adding this file to the project root provides a set of behavioral constraints that prioritize stability and maintainability over rapid generation. It also integrates with any pre-existing project-specific guidelines or formatting rules already scattered throughout the repository. A static, universally applied configuration file enforces architectural discipline with a level of consistency that fluid, human-written instructions cannot match. The file introduces 4 behavioral principles. The first is think before coding, which explicitly bans the model from hiding its confusion behind generated text. This rule forces the AI to state its assumptions explicitly. If ambiguity exists in the prompt, the model must halt and ask for clarification rather than guessing. The second principle is simplicity first. This mandates the absolute minimum amount of code required to solve the immediate problem. The AI is forbidden from adding unrequested features, abstract configurability, or speculative future-proofing for scenarios that do not yet exist. The third principle is surgical changes, which restricts the model to touching only the exact lines of code mandatory for the current task. This eliminates drive-by refactoring. If the AI-specific edits create unused variables or dead imports, it cleans up its own mess, but it leaves pre-existing dead code alone. By imposing these 3 rules, the developer prevents the LLM from generating collateral damage to the surrounding architecture. The final principle dictates the execution methodology, goal-driven execution. This method changes the interaction model, moving from generic imperative instructions to strict declarative goals. Giving an AI a standard imperative command like add validation allows it to guess the parameters and write untested logic. The system transforms requests into a verifiable standard. Write failing tests, then make them pass. This establishes a loop. The AI generates a failing condition, edits logic, and tests again. When the test passes, the loop breaks, finalizing execution. The exact same logic governs all bug fixes. The AI must write a test that accurately reproduces the bug before it attempts any structural changes to the codebase. For multi-step tasks, the model is required to state a brief plan and define clear success criteria before writing a single line of logic. Weak criteria, like make it work, demand constant human intervention to correct course. Strong, testable criteria enable the AI to loop until explicit conditions are satisfied. By leveraging test suites as strict verification loops, engineers eliminate AI drift. The code generation is bound by specific passing criteria rather than probabilistic guessing. Implementing this level of strict constraint introduces real operational drag. The system can easily overreact to minor, trivial tasks. The core limitation of this configuration is its bias toward caution over speed. Utilizing this strict multi-step verification loop for a simple typo fix turns a 5-second job into a rigid architectural ordeal. Engineers must use their judgment. It is necessary to bypass the full rigor of the system for obvious one-liners. The purpose of this tool is reducing mistakes on complex infrastructure, not hindering rapid iteration on simple tasks. This text file forces developers to reconsider their assumptions about the future of software development. Are we genuinely training AI models to write better production code? Or, by requiring clear success criteria before a single line is generated, are these rigid LLM constraints actually training us to write better test-driven requirements? AI leverage in a production environment is achieved through strict constraint, not absolute freedom. If this saved you time, hit subscribe. We review tools like this every week, so you're always ahead. Now, if you liked this optimization hack, you're going to love our breakdown of AI code-based workflow automation. Click the video on your screen right now to keep learning. See you there.